I just need to stop and continue with a new video. Okay, number. So in 20 we have x plus y equals -11. And something very ugly, x minus 3 squared plus y plus 6 squared equals 34. Can anyone tell us, this is not necessarily here, it's not the question, but can anyone tell us what this resembles or what does this represent? Yes, centered at 3 comma -6 with a radius of the square root of whatever that is. Perfect. So we're asked to solve this system. Remember, the variables are not the same. So one method I have to eliminate completely. It's not potential method here, which is elimination. It's not possible. The variables are not the same. I can eliminate. But what I can do is what? Use, if it's not elimination, exactly. It doesn't matter which one you want to substitute for. If you substitute for x, then you have -y minus 11. This has to be replaced in the second equation. So let's see what we get. -y minus 11 minus 3, everything squared, plus y plus 6, everything squared equals 34. This is not a pretty equation, but it's not super sophisticated either. It's quadratic. But I have to be careful. I have to combine like terms. I have to be careful when I square because I have to get how many terms? Careful? When I square a binomial, no, so I'm going to combine these. So 3, and for also here 3, and then proceed. Okay, so let's do that. So -y minus 14, everything squared, plus y plus 6, everything squared equals 34. Now, when both terms are negative, just a quick reminder, because I don't want you to get entangled in this somehow. Remember, this can be rewritten. Would you agree with this? I factor out -1 from both, but I still have to copy the power. But when I have a -1 in front, I still have to square that too. So this is still the same thing. So if both are negative, and both terms are negative, and I have to square them, it's like squaring both positive, because I have to square this -1 as well. So when it's okay, you can say, well, I'm going to square and I'm not going to get any term negative. That's fine too. But it's easier if you think in terms of factoring out -1. You still have to square it because it's inside the square. So it's -1 squared, which is 1. So squaring this is squaring this. But this is not the same. Squaring this does not mean squaring this. It's a totally different story. But if both are negative, it's like squaring this. But these two are not the same. So the first term squared is y squared plus 2 times the first times the second, 28y, plus 14 squared. And then plus, thank you, y squared plus 12y plus 36 minus 34 equals 0. You would have gotten the same answer, right? -y squared is y squared. And then you would have said plus 2 times this times this. So they're both negative, so we're going to get positive. And -14 squared, you're going to get plus 186. But I don't want you to get afraid of those two negatives, right? Okay, so then I have to combine 2y squared. Then this is plus 40. And let's see what we have. This is positive 2. So plus 198 equals 0. Of course, I will do what first? Yes. So y squared plus 20y plus 99, I think. So what is 99? It's only 3 times 3 times 11. Can I get a 20 and just factor quickly? Or if you say no, then we'll have to use the quadratic formula. The sum is 20, the product is 99. So there are two options for y. Is this good? Yes, but not good enough. So I have to go back here and determine the corresponding x. When y is negative 11 with minus in front is positive 11 minus 11 is? Now when this is negative 9 with minus in front will be positive 9. 9 minus 11 will be negative 2. So we claim two ordered pairs as solutions. And they are, careful in the correct order, and negative 2, negative 9. Do I know whether they work? No, I have no clue. I have to go back. I'll go back here. 0 minus 11, check. Now 0, negative 11. 0 minus 3 is negative 3 squared is 9. Negative 11 plus 6 is negative 5. Negative 5 squared is 25. 9 plus 25, 34. Check. Now I have to go back and check negative 2, negative 9. Negative 2, negative 9. Check. Negative 2, negative 9. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. Negative 11 plus 6. I'm sorry. Yes, I would see what I did. Negative 9 plus 6 is negative 3 squared is 9. Sum is 34. So I'll say yes. Okay. 21, 22. Which one? Okay, very good. Find the length and the width of a rectangle whose perimeter is 34 feet and the area is 60 square feet. Okay, so we have a rectangle, XY. We are told the perimeter is 34. We are told the area is 60. What should I write? How do I write the perimeter? Say it again. So 2x, 2y equals 34. That's the perimeter. And then the area. Very good. X times y equals 60. What kind of system is this? And the answer is nonlinear. You may see x with power 1 and y with power 1, but this is a product. I will definitely simplify the first one into x plus y equals 17, just because I can get rid of some numbers and make it easier to work with. So that's one thing. But then I have to solve the second equation, either for x or for y. I have no choice. I cannot eliminate. Although you see the same variables, but this is a product. Totally different story. So from here, I either have to solve for x or for y. If I solve for x, what do I get? over y. It's multiplied. I cannot break a product unless I divide. So then I go back to the first equation and I get 60 over y plus y minus 17 equals 0. What do I do next? Exactly. But because we cannot really multiply by y, in this case we can because y is not 0. Remember, you cannot eliminate and multiply both sides by a variable or divide by a variable. In this case, you can say I can because y will never be 0. I would have to agree with that. But you can never multiply or divide both sides of an equation by a variable. So this is 60 plus y squared minus 17y over y. And cross multiply. Y squared minus 17y plus 60 equals 0. So let's see what is 60. 60 is 2 times 3 times 2 times 5. 6 times 5 times 10. If I can get a negative 17 with two negative numbers from here, fine. If not, forget it. Quadratic formula. I can? They both have to be negative. They both have to be negative because the product is positive and the sum is negative. So yes, negative 12 and negative 5. The product is 60 and the sum is negative 17. Negative 12 and negative 5. So y minus 12, y minus, oops, equals 0. So y equals 12 and y equals 5. Is that clear? So now I have to put in 12 here. How much is 60 over 12? And then I have to put in 5 here, and I get 12. So what are the possible ordered pairs for the system? Exactly. I have to go back and check, but it's clear. Their sum is 17 and their product is 60 no matter what. Okay, what are we doing next? Say it again. 22, very good. Y greater than or equal to x squared minus 49, and x minus y greater than or equal to negative 7. Okay, so we start with the equation first. I know exactly how to graph this because we graphed it so many times. What is the base function? Very good. And then where do I shift it? Careful. I'm not changing x, but I'm changing y. Very good. So 10, 20, 30, 40, 50. So it's going to be here. And obviously, where will it cross the x-axis? When y is 0. X squared minus 49. Very good. So if this is 10 and negative 10, this will be this negative 7 and 7. Very good. This is indeed y equals x squared minus 49. And I should have stopped and asked you, can I draw it as a solid curve? I should have asked that before drawing it. Yes, correct? So I'm going to pick this point because it does not pass, the curve does not, or the function in this case does not pass through the origin. 0, 0. Is 0 greater than or equal to negative 49? If you say yes, I'll shade in the inside. If you say no, that's false, then I have to shade in the outside. True. So I have all this. All points inside represent solutions, ordered pairs, solutions to y greater than or equal to x squared minus 49. I will repeat for x minus y equals negative 7. But this is what type of equation? Perfect. When x is 0. Very good. So 0, comma 7. When y is 0. So negative 7, comma 0. Do I draw it as a solid line, solid curve, or not? 0, 7, and negative 7, 0. Solid curve or not? Very good. On the line, I write x minus y equals negative 7. This is not the inequality. This is just the equation. I will choose the same point because it's the most convenient. And I'm checking the bottom region. So 0, 0. Is 0 greater or equal to negative 7? If you say yes, I'll shade in the bottom. If you say no, I'll shade in the opposite. Yes. So all these points in the green territory represent ordered pairs that verify this inequality. But I'm interested in the entire system. I don't want the green. I don't want the red. I want green and red at the same time. Is there such thing of green and red at the same time? Yes. Points on this line, points on this curve, and everything else. We used to do linear programming. The next section is linear programming. I don't know why we took it out. This is the basic, the first step for linear programming. So both. Okay, next one. Let's look at the log equation. Like 13. Ready? Which is log base 2 of x plus 6 plus log base 2 of x plus 5 equals 1. Okay, we know that log is or is not a friendly function. It's not. So then I have to state the restrictions for this. X plus 6 must be greater than 0. The restrictions for this. X plus 5 must be greater than 0. This one is greater than negative 6, and this one is greater than negative 5. Which one is the common domain? So I know if the solution is not in the common domain, it's out. Very good. So negative 5 to infinity. If the solution is somewhere between negative 5 to infinity, is that clear why? If the solution is not here, it cannot be accepted. Or you can say, forget it. I am not going to state the domain, but I promise to go back and check. It's fine too. It's up to you. I need to condense the left-hand side. How do I condense it? Log base 2 of, very good. And now this is equivalent to which exponential equation? From the base. counterclockwise. 2 raised to the first power equals this. So this is x squared plus 11x plus 30 equals 2. 2 to the first power equals this, and I already multiplied it here. X squared plus 5x plus 6x plus 30. Quadratic now, and subtract 2. If it takes more than 15 seconds to factor, forget it. Quadratic formula. I need two numbers whose product is 28 and whose sum is 11. Awesome. So then it appears that the equation has two solutions. What are they? With a big question mark. But I made the effort to present or determine the common domain. What will I say? I will say no, and I will say yes.